Great, everybody. Welcome to this LSLC seminar, Data at a Distance, the Art of Remote Inspections. As a center of multidisciplinary education, the LSLC holds a series of monthly seminars hosted by our corporate members and usually held at various venues in the City of London, where maritime experts, legal, commercial, and technical, address industry delegates on current and challenging topics. The center also organizes special events, workshops, mock trials, and mock arbitrations. The four pillars of the center are leading maritime education, connecting maritime professionals, sharing knowledge and creating synergy, and educating a wide spectrum of shipping professionals. But as these are not usual times, but interesting and extraordinary times, today's webinar is being administered by LSLC, hosted by ESI, with contributions from MAIB and CLS Europe, a truly international event. This webinar will deliver a high-level view of what to expect when attending a live remote inspection. The first presentation compares the traditional inspection process with the remote access experience and highlights technical and legal pros and cons and pitfalls of a live remote access inspection. Then the MAIB will give a short presentation on the importance of independent evidence gathering in marine accident investigations. And then we'll wind up with CSL Europe giving a short presentation on the potential impact of unmanned air systems, more commonly referred to as drones. And one final advert before I hand over to Chuck is you may see in my initials after my name, CMR, that means Chartered Maritime, Chartered Master Mariner. And if you have a master's ticket or command qualified at sea, please have a look at the Honorable Company's website and take an interest. Thank you very much. And Chuck, over to you.
Thank you so much, Les. I appreciate the introduction. We are so excited to be here today with you all. As you mentioned, it's a truly international presentation, which really makes this exciting. We're excited to be here with Andrew from MAIB and Alex from CLS Europe. I'm excited to see their presentations. We're going to kick it off here talking about remote inspections. And I think that's going to be an exciting topic for you all. I'm going to be presenting with my colleagues here. Les, you already heard from him. He's going to be part of our presentation. Dan Turner, who's located in our Houston office, is going to be a portion of the presentation as well. And Dan brings some really awesome marine experience to the table, in addition to doing a number of these kinds of inspections. Matt Kenner and I present this on a number of occasions. Matt's got a lot of experience as a senior managing consultant in our organization and has participated in a number of remote inspections. I'm the director of technical services at ESI, and my team, his responsibility is really documenting these inspections and providing a nice live feed of the inspection experience. And we're going to give you a live taste of that today when we go to our labs in Atlanta and Aurora. So with no further ado, I'm going to hand it over to Matt Kenner to give us a little bit of introduction.
Hi, everybody. So we'll start with a discussion of the traditional inspection process, and just for a little bit of clarity, we're using the term inspection here in the context of examining a ship or component or vehicle as part of an investigation of an incident or an accident. I think later on, Andrew's going to use the term inspection a little bit differently, so I wanted to make sure we all had that context for the purposes of the two presentations that you'll see today here. So first, and maybe most obviously in this time, the traditional inspection typically results in attendees being physically close to one another, and the term social distancing is not something we knew of maybe 6 months ago, 5 months ago, but now we do. And so that is a key part of the traditional process, which causes you to think about going remote. Another part of the traditional process is often a number of folks taking images of the same thing, and the paparazzi, as it were, and lines of folks taking images of the same thing, and that can get time consuming and complicated and duplicative, obviously, but it's something that you see a lot. Now, that being said, there's obviously important aspects of being there in person that are hard to replace with your own eyes. It's still the best way to gather a large amount of information, to be there full ship. I do a lot of aircraft accident wreckage inspections. Sometimes you're looking for a particular component in a crate filled with an aircraft wreck. You just can't replace being there. And we're not promoting replacing being there, but there are some things with the traditional inspection that actually might work better in the remote inspection. Some other things that might be complicated for the traditional inspection are confined spaces, hazardous environments that might require special training, those types of things. And as you'll see here in the coming minutes, the ability to be remote might actually offer some advantages in that. There's also some advantages potentially with remote. In the traditional process, much of what you do isn't necessarily memorialized in any meaningful way. As you'll see here, we'll have the opportunity to memorialize quite a bit more of an inspection if you go remote. So the biggest benefit, obviously, for remote is efficiency. You save time and travel. In the current environment, you might not even be able to travel. In this instance today, right, distance could be an issue. You're going to go live today to Aurora, Chicago, Illinois, and Atlanta, Georgia, thousands of miles away, but you'll be live in the lab in the United States. Another benefit might be the possibility of opening up an inspection to folks who might not otherwise be able to attend because of work commitments or economic considerations, other people on your legal team, consultants who you might not be able to justify attending an inspection, but now could. There could be a key portion of an inspection that there's 4 hours of cutting and removing things to get ready for a particular test, and that's the key part of the inspection. Key personnel could skip the 4 hours building up to that and attend remotely the key test or the key part of the inspection. We talked a little bit about confined spaces, and one of the presenters today will talk about one of the key ways to avoid getting into a dangerous situation like unstable structure, and that'll be with drones. You'll see the opportunity to put cameras and give views to folks that you otherwise couldn't. And it might be simpler than a confined space or hazardous environment. It could be the removal of components. I think many of you probably have seen when you get a large group of folks, a single person might end up, you'll see a demonstration with a flame arrestor and a torque wrench. A single person ends up on the torque wrench, and many of the people in the room might actually not get a good view of the removal process of a component or the measurement process. And the remote inspection offers the ability for everybody to have a front row seat, which you'll see here in a minute. Of course, as you move forward from the field into the lab, you start moving closer in and focusing on more narrow things, maybe subcomponents, maybe doing stereo microscopy, maybe doing SEM. Those types of things are often shared data. And in that case, the feasibility of remote inspection definitely comes more into play, because ultimately you end up looking at a screen even if you're sitting in the room, and you can just as easily do that remotely. And with the remote techniques that we've developed, you can share data real time, photographs, data off the SEM or the stereo microscope, and all those things are shared through something we've called the portal, which Chuck will explain.
So it's important to understand, as Matt introduced it, there's really two components to a successful remote inspection. And those components consist of, one, the live experience, which we've been talking about, and I'm sure you all anticipate. Look, I'm going to have some live views into this laboratory space or this field environment so I can see what's going on, and that's pictured on the left. But also, an important component is something that we call a portal. And a portal is basically a secured web space that all of the participants or a particular subset of the participants in the live portion of an inspection can access files that are being generated during the course of the inspection. So you see in the left panel, Pierce has taken a photograph. You're going to see some of that live coming up. Those photographs can be uploaded to the portal in near real time. So within 10 seconds to a minute or so of that photograph being taken, that can be available in the portal, and you can have access to this nice high resolution photograph. And because you have two-way communication with the team in the lab, you could request a photo. You could say, hey, could you take a photo a little bit to the left, or maybe zoom in a little bit more on this feature? It's not a passive experience. It makes it an active experience in data gathering as well. And in that portal, we can host a variety of things. Those photographs or perhaps video of another inspection that happened during the course of the matter can be available on demand for other participants. So let's say someone wasn't able to attend, maybe they're coming into the process in a matter later in the game and they want to catch up, they can go back and watch previous inspections or look at photographs from another event. You can house important documents in the portal as well. So you can grant access to those who are going to be participating in the inspection and host protocols and things like that in the portal. So everyone has a central location for that information that's going to be important to the live event that's coming up, or perhaps live events that happened. So scheduling can also be done via the portal, and in this first segment, we're going to do a field inspection. We'd love to do everything live, but in the interest of time, we've sort of recorded an event that Dan is going to narrate for us that we did yesterday in the Houston facility. And so this simulates kind of a field inspection environment where you may be out, in a remote area, have a few camera feeds, but still want to bring folks in on a remote basis. And I'll let Dan take it from here. Dan?
All right. Thank you, Chuck. So I'm a professional engineer. So what I would be doing in a scenario like this is I would be hosting this inspection and developing the protocol, as well as maybe dealing with any particular issues on site. And you'll see with me in this video, I had Mr. Aaron Zemer with me. He's a senior technologist, and so he has the skills to recover some of this information and actually work with these items. So this is our mock demonstration for you, and as Matt said, this is this is something that can happen in a variety of places. This could be a shipboard piece of equipment still installed. This could be in a difficult area to access, such as hanging off an offshore rig, confined spaces, hazardous spaces. There's quite a bit of environments that this could actually be in, and of course, that's where the inspection needs to go. So it could also, if they might remove this and have it in a scrapyard or something like that, or as you see today, this is in a laboratory environment. And just give you a little bit of a background on this particular piece. This is called a flame arrestor. This is used in piping systems where you're trying to protect equipment that is downstream in this system. So if you have a flame progressing through the piping circuit, it gets to this device, and this device can actually stop the spread of that flame further downstream and protect the equipment downstream, including explosion hazards and things like that. Not that's particularly important for the inspection today, but part of the way it does that, this is a mechanical device. It cools down that flame as it's progressing through the circuit, interrupting the fire triangle, and it needs to do that for a certain period of time. And so you can see that this particular device is burned a little bit potentially. And for our demonstration today, we're going to assume that maybe the experts are interested in this being overpressurized. And so we're going to investigate the bolts, assuming that the experts, a part of this investigation, wanted to recover the preload in those bolts. And I'll just give you a little bit of background in that. Those bolts apply a compressive force to those two flanges that you're seeing. The two halves of that device are held together in compression. The bolts are in tension, and then the hardware on those bolts are torqued such that they have that preload, and that force applied is going to correspond to the torque applied to the nut. And so that's what we're going to be looking for today, is the corresponding torque. And in this case, the reference torque is going to be 100 foot-pounds. That's just a data point that you'll see when we're actually collecting this data shortly. So in this process,
sorry, Dan.
A little bit. No problem.
Let me get it rolling.
Okay. So in this process, when we're actually investigating this piece, should I just jump in, Chuck?
Yeah, just go ahead and continue. For some reason, the movie's not rolling for me here. Let me get that going for you.
Sure. So what we do in a situation like this is we're going to actually use what's called a torque wrench. It's a calibrated device that, it's a large wrench with a digital readout, and we can apply a force on that. Okay, here we go. And so this is the basic documentation phase. We want information like the nameplate. This is something that all the experts are going to be interested in. So we're going to get that sent out live, and we can distribute that as a photograph as well. And then the valve positions, people want to know, is this fully open, fully closed, partially open, partially closed? And so that's something we can recover. You can see that we're physically marking the parts that we're going to investigate. We have identifying marks number 1 and 2 for the bolts, the hardware, and the flanges. Then we also have positional markings, those tick marks that you're seeing, so we can verify whether or not the threaded rod is moved relative to the nut or the nut to the flange. So this is the device we use. 100 foot-pounds again is our reference torque. You'll see some lights indicating whether or not we're approaching that reference torque and whether or not we've exceeded it. And away we go. So this is on item number 1, and Aaron's going to torque up the bolt, and then you'll see an indicator and then red indicator. So this particular bolt made it to 100.8 foot-pounds, which exceeds our reference torque. So in this case, we're going to interpret that as being torqued at least to the appropriate torque. And then we're going to go to setup number 2. We're going to start torquing it again. Then we see that slip. And then it made it to 60.4 foot-pounds, which is less than our reference torque. So we're interpreting that as not being torqued to its reference torque. And then you're going to see Aaron's going to indicate that those 2 tick marks are now misaligned, whereas in number 1 they were not. And just a little bit of a close-up view. It's a little bit hard to see with kind of the glare. That's something we can work with when we're working live to kind of get you a better view. But the tick marks on the threaded rod and the nut are aligned, but on the nut to the flange, they're misaligned. And that tells us that the nut has slipped relative to the flange. So that's our example of recovering some scientific data in a logical and repeatable way in an investigation that was held remotely. And of course, we could have done that with the same efficacy that we do that in person, and that's the general purpose of this. So thank you. And Chuck, back to you.
Excellent. Thank you, Dan. We appreciate you taking us through that process. So, the field presents certain challenges, but the lab gives us an environment that we control. And so we can set up really elaborate circumstances in the lab where we can provide not only live camera feeds, but we can also instrument devices. These are often hosted with multi-parties, and that can add, another wrinkle to the process, in that it's important to define those protocols in advance and exactly what's going to happen and how we're going to do it and what we're going to record in the lab. But what we want to do now is show you a more elaborate version of the remote inspection. And we're going to go live to one of our labs. And before we do that, I want to make a note to anybody that's joined late. What we want you to do is right-click a screen. You should see one that says ESI Live. If you were here early, you already did this. Scott, maybe you can give us a little audio and pop that ESI Live screen to the front. On the bottom of your screen, it will show up as AP. Yeah, Atlanta Production. Thank you. Just right-click that and pin it. Right-click Atlanta Production or the ESI Live logo and pin it. And that way, that will be your dominant frame for the lab inspection. And Scott, go ahead and take it away when you're ready. So we're going to switch to a live view of Atlanta.
Yep. So this is Dr. Pierce Umberger in our ESI's lab in Atlanta, Georgia. How you doing today, Pierce?
Doing all right, Matt. How are you?
I am doing well, thanks. So as you can see, we've got live two-way communication, and Pierce is demonstrating taking some images here, and those images would be uploaded live to the portal. So usually within a minute, in our experience, you'll be seeing the high resolution images that are being taken by Pierce with his DSLR camera. You saw a field demonstration with the flame arrestor. There's the portal. That was a simple kind of one camera setup. When you get to the infrastructure that you might have available to you in the lab, it can get quite a bit more complicated. As you can see the portal here, you can have an overall of the table where the part is. In this case, we've got a motor there. You can have an overall of the lab. You can have a close-up view of the component itself. You can see that's actually inset in the overall of the lab. And there's an opportunity to do a 4-up. You might have multiple things going on in different locations. And you can send out a feed that allows folks to remotely monitor a number of different things that might be going on. So another thing to point out here is we might be looking at a single feed. All those other feeds that you've seen with the different angles, they could all be recorded. That's something the parties that are attending this inspection might discuss beforehand and make part of the protocol. But the feed you're seeing live here with Pierce working on the motor, the overall view of the lab, you may have other components off this camera view. Those could also be recorded, even though the live feed is just this image. So I think what we're going to do for you today is let Les in London interact with Pierce in the USA and go through a little bit of back and forth with regard to the inspection of this motor.
Les, I did have to go ahead and mute you. Could you please check your mic quick?
Hi, Pierce. It's Les.
Hey, Les. How are you today?
Yeah, good. Yourself?
Doing great.
Good. Does the bearing come off the end of the shaft?
Yeah, so there's looks like a bearing and balance shaft here with looks like a clamp screw. I think we can go ahead and loosen that.
Good.
Take this
Can you
bearing
take it off? Yeah.
Absolutely.
And can you measure the diameter of that shaft?
Sure. So I've got a set of calipers here. It looks like the diameter of this shaft is about 0.787 inches.
Excellent. And are those keyways in the end of the bearing stub?
Yeah, it looks like we've got a set of 4 keyways here. Two of them are large, and looks like 2 of them are quite a bit narrower.
Right. And how wide are they?
Let's see. So probably the easiest way to do that is if we hop over to one of the optical microscopes and take a look at that.
Excellent.
Let's go over here to this optical scope. Hopefully you can see my view here. Let's get a little bit better light. So there's 4 keyways here in the end of this shaft. Let's go ahead and measure. So this is a large one. We're looking at about 0.28 inches on these large keyways, 0.28, 0.29 inches. And approximately 0.21 inches on these small keyways, it looks like.
So this is the type of data that could be shared across the portal. So you're seeing it live on the screen, but it would also be pushed out to folks attending remotely so they can get the opportunity to basically real-time digest the data that's being developed during the inspection, which is not something that often happens in a lab inspection. There's often just logistically delays of a couple weeks at least before you get that data that you may be developing in the lab, which sometimes can be an issue. So we worked a little bit on the stereo microscope here. Oftentimes the stereo microscope, which can magnify things up to about 100x or hundreds of x, leads into an SEM exam. We have something in the SEM chamber in our Chicago, Illinois labs to kind of move down the next step that you might see in an inspection like this. So that's the operator in Chicago, Daniel Stange. Good morning, Daniel, or good afternoon for you.
No, it's still morning time. We're before noon here.
There you go. We've got people all morning, afternoon. I don't know what time it is. So the SEM is kind of the ultimate example of where a remote inspection can be very, very workable. The item being examined in an SEM needs to be in a chamber. You can see the box to the left of Daniel. That's a vacuum chamber. So even if you're live in the lab watching an SEM exam, you are looking at a computer screen over the shoulder of the operator or a monitor up on the wall because you can't physically see the piece. So the ability to watch remotely from, in this case, half world away is basically the same experience as watching it live in the lab in Chicago. And there are actually some added benefits with this. We talked about the ability to push data through the portal. He's demonstrating something called EDS, which allows you to measure the elements that are present on the surface of the sample being examined in the SEM. And this is the kind of data that most people in the room are very interested in, but it's also the kind of data that kind of gets pushed through and moved through, and you get a quick look at it, and then you move on to a different section of the piece. With this being uploaded to the portal, you have the opportunity to basically do a live assessment and study of the data that you're gathering because it will be available to you to look at offline on your computer remotely, something that wouldn't be available to you necessarily in the lab. So it's a great example of where a remote inspection is actually maybe beneficial. So you might be interested in how we make all this work. We've got cameras in Georgia, we've got cameras in Illinois, we've got maybe 8 or 10 cameras in total. Chuck is going to bring you through how this setup works at a high level.
Right. So thank you, Matt, and thanks to everybody in the labs that were on the live inspection. What really is happening behind the scenes as the camera was magically changing from one proper view to the next one was an online producer, Scott, in our Atlanta lab, had a feed from all the cameras, all the instruments that we needed to use during the course of the inspection. He has a feed at his producer's camera. You can imagine him like the I guess in this case it would be the BBC producer outside of some sort of event who is monitoring a number of different cameras and can feed just the right one at the right time to the newscast or the sportscast. And so he's the difference between that and the BBC producer is that he is actually pushing that feed out to a two-way communication. So via Teams in this case, it could be other screen sharing tools. Scott can produce the audio and video from any of the sources, push them out to a group of remote participants, just as we did a moment ago. And any of those participants can have two-way communication. And that really, I think, unlocks a special thing that happens in the lab. And that is that it becomes not simply a passive experience, but one that allows you a certain level of participation in what you want to see in the lab. You can interact with the engineer in the lab that's conducting the inspection. You can interact with the producer and ask for specific views. So there are, as we alluded to, there are considerations for going remote in the field, and those challenges are usually associated with the environment that you're operating in. Things often have to be transported or shipped to a site to be available for the inspection. If drones are going to be used, we need to understand the flight restrictions and things. And of course, weather impacts our ability to fly. Power and network connectivity are critical. If we can't get a good internet connection, we can't deliver that remote experience. And so, coming up with means of delivering that remote inspection capability when you're actually remote and may have to use a cellular network can be a challenge. So in field arrangements, a plan B is often very important because you're usually executing on a plan B or maybe a plan C. In the lab, it's a much different environment. We have an internet connection, we have power, we have lighting, we have all those things that we need. Those come easy in the lab. So really pre-planning is what's critical for a lab inspection. It's typically a much more elaborate kind of event. And so knowing what things need to be instrumented and what things we're going to have to live feed is important. So we have everything ready to go on the day of the event, and we don't have to stop to wire up maybe a piece of equipment we hadn't anticipated using. The other thing that's important to understand, I think, about this mode of accessing information is that the remote access doesn't really end at the time of the inspection. We collect a lot of data in the course of the inspection, and some of it may be photographs and things that are easily visible. Other things may be things like 3D data. And so this is an example of a laser scanner that collects three-dimensional data, and it, through the course of about a 12-minute scan, creates information called a point cloud that gives us not only a visual representation of a space, but it also gives us metrics. We can measure any of the components in the space. Now, in a setting like this, in an oil refinery, we might spend a week laser scanning this after an explosion or a fire. You don't really want to be remoted in for that. But what you do want to be remoted in for is the data. So this is an example of a barge that we scanned. It was involved in an accident. We had to catch it when it was underway. This was on the Mississippi River, fairly close to our Illinois office, and we caught a laser scan. What happened was a worker was badly injured in the rudder room in this particular barge. And so we needed to capture an accurate 3D space so we could do things like surrogate studies and things like that to try to figure out what had happened with this worker. You can see here a laser scan of the rudder assembly. This particular barge has a fairly complex set of rudders in it, and the worker was actually injured when he got entrapped in the linkage of one of the rudder systems that he thought was inoperative at the time that the barge was in motion. You can see that you can take all kinds of different views of this after you've collected the data, because the data is 3D. So the act of collecting the data takes a certain amount of time, but once you have it, you can interact with it in a really detailed fashion. In fact, you can create views that might be quite similar to that worker's view in the room when you have information on, where they might have been standing when the event occurred or what sort of sequence events might have happened. And in fact, it's so immersive to do this kind of thing that it's tempting to enter these spaces using VR. And in fact, we do that quite frequently. These are some shots from the VR labs we have around our organization. And, before travel restrictions, we used to invite groups into our VR lab, and, someone would don the head-mounted display. Usually it was the consultant that would be sort of a tour guide to the space, and they would walk a team through the space while the team watched on a television screen and got a guided tour of some 3D space and maybe worked through a sequence of events that might have happened in that space. Now, that sounds pretty solitary now, and it is when you're the person that dons the head-mounted display, but we can actually send that experience out remotely as well. Just like the folks that would come in and into the lab and watch it on a screen, we can push that screen share out just like we're doing in Teams today. And when you do that, it looks something like this, where you're essentially adopting the view of the person in the head-mounted display, but you don't have control over the environment. You're just sort of riding along with them as they navigate a space. This is a space that we spent a lot of time inspecting. It was a home that involved a tragic accident involving an in-home elevator. A child became entrapped in this elevator system, and it was an utterly unwitnessed accident. And so we spent a lot of time trying to determine what was the sequence of events. How did this child become entrapped in this elevator system? And so we built a digital replica of this house. We had access to it once, and we laser scanned it. And then we used this digital replica to interact with the home again and again and again in different ways, and in determining what happened in this particular sequence of events. And then ultimately, visuals generated from this space were used as part of a mediation process. We can do that in vessels too. So we can not only take you, inside a home or inside we can take you inside of a moving vehicle. So we can do this with ground vehicles, with aircraft, with this is the Eagle Atome, a tanker that was proceeding upriver toward Port Arthur, Texas, when it collided with a barge. We can give you the point of view of the barge pilot, of the captain of the Atome, the pilot of the Atome as it was coming upriver. And we can do that all in real time. And we can include, transcripts, information, radio communication and things like that during the course of the event. This is the kind of thing that we would work through in VR from those initial scans and the initial information we had, and then ultimately render something for a mediation, an arbitration, a court proceeding that would look like this, that we could put up on the screen and use during the course of the trial. These can be, quite dynamic. As you can imagine, in aviation accidents, things happen extremely fast, unlike maritime accidents where they sometimes happen almost in slow motion. But nonetheless, having this witness eye view, this operator's eye view, can be extremely valuable when you tie together this sequence of known events. In addition to, sort of the solitary VR experience, we can also deliver a multi-user VR experience. And this is especially important in the context of inspections, because it gives each individual autonomy in terms of interacting with a digital twin of some particular object we're interested in inspecting. So rather than being drug along in a guided tour, you actually come in, you have an avatar, you can see each other, you can interact with each other verbally, and you can do things like measure things and drop points of interest and snap to other points of view. And that looks something like this. So here we have multiple users in an inspection. We're actually recording the view of user one. And, you can see that we've got 3 users here interacting with this rail car with a modal container on it. One of us has a head-mounted display and hand controllers, so you can see the hands interacting with the device, and you can freely move around. User 4 and user 3 are using a PC. They don't have a head-mounted display. They're just viewing via their PC screen, but they still have the capability of moving around this 3D object and interacting with it. They can still take measurements. And in fact, you can see in this view, we can get lots of people involved in this. I think there's 14 users in this, scattered all around the US. So, physically distant, but virtually in the same space. And I'll tell you, from interacting in a number of these, it's a pretty weird experience. I mean, you sort of lose track of the fact that you're physically distanced and you just interact with one another in this virtual space. There are other instruments that, due to the, their expense and the magnitude it takes to have them, are sort of unicorns, in our laboratory facilities. And we have one, large industrial CT scanner in Dallas that we use extensively in inspections for non-destructive components of an inspection. And so much like you saw us earlier carrying out an inspection in Atlanta, but using an SEM in Aurora, we will often bring in the CT scanner from Dallas for an inspection. So a component that we want to CT scan may be sent to Dallas so we can look at that. And sometimes that's in real time. And so there's these moment of truth events like this ball valve where we wanted to understand, was this valve functional before we cut it apart, and arguments could be made about whether it was actually working or not. So we could put the valve inside the CT scanner and create this X-ray movie of the valve being actuated, and we could see that it was actually working before we did anything destructive to manipulate the valve. So again, remote access can be super valuable with something like this, because all of a sudden it becomes part of an inspection that might be being conducted in Aurora or Atlanta or some other location. In terms of takeaways from post-inspection analysis, I think these sessions, as far as remote participants go, are a little easier to manage because they're often, unlike an inspection itself, they're often not multi-party. And so they can be a little more freewheeling in terms of the conversations and things like that are had during the course of these kinds of events. There are multiple ways, to remotely access these. Like I said, with a VR, we can simply screen share them with tools like WebEx or Microsoft Teams, or we can go, into full-on VR application sharing and bring in multiple users into that virtual space. And any of these experiences can be recorded for later viewing. So if there's someone who can't attend, they can view it. If there's a test that we want to record, we can do that in one of these post-inspection analyses. If there's particular views of the data, we can provide those. So these are important for many stakeholders to be involved in, because these events often lead to decisions that take you to the next thing. Interacting with, for example, that laser scan data virtually may tell you what the next steps are in terms of maybe introducing a surrogate into that 3D space, or animating, the movement of the rudder linkages in the, in the tug. There's often decisions made that tell you what the next thing is going to be. As far as technical considerations, it's important to keep it simple. The technology can and will bite you at times, and so keeping it simple minimizes that. A skilled stream producer, as you saw from the Atlanta experience, can make it, just an incredible event. That person is someone who you never see, but is key to making the event go smoothly. As I mentioned in field inspections, plan Bs are important, and that's always the case. I think you always want to know what you're going to do if a camera fails or something happens that may preclude moving forward with the inspection. You want to have a plan V, and you want to plan on what you can do with the technology, because you have the opportunity to provide unique views, perhaps by putting a drone up or using 360 cams in confined spaces. And that backup plan, again, I can't say that enough. There are legal considerations that one needs to keep in mind around this, and I'm sure those have been rolling through your heads as we've been showing you all this technology. Careful and advanced consideration of protocols is critical. Everybody needs to know what's expected in this, because you're going to have people remote that can't interact physically while they're there, and so setting expectations for how this is going to go is critical. Decisions on whether to record audio and video are critical. Oftentimes audio, we do not want to record audio during the course of the inspection. We want to keep it a live event. And so we'll forego recording to just make it live. You probably want to set some constraints on recording, because it would be easier for someone to, for example, plop down their iPhone next to their computer and record conversations during the course of an inspection. So the protocol should define those rules. Privileges and work product protection are something to consider in this format. And, who's going to attend? Are you going to make a witness if, someone from the company attends this that you'd rather not, have them become a witness? Obviously, there's, some big benefits and cost savings and value added by bringing in, people that you might not, spend to have them travel to an inspection or burn the amount of time it would take to be at the inspection. They can spend a short period of time and attend remotely. So that's our presentation. I think we want to go to the next person in the order, which I believe is Andrew from MAIB. And I will stop sharing my screen, Andrew, and let you have the feed.
Great, thank you very much indeed, Chuck. So let me just get myself set up here. Chuck, can you just give me some feedback? Have you got the MAIB?
Yes,
first
we're
screen?
seeing it first slide. Perfect, Andrew.
Brilliant. Thanks very much indeed. Right. So, yeah, Andrew Moll, Chief Inspector of the UK's Marine Accident Investigation Branch. And I'm going to talk a little bit about accident investigation, very much in the COVID context, where travel is particularly challenging. I think early engagement, the early stages of any investigation, important for getting the direction of the investigation going off in the right in the right direction. We're always going to get there in the end, but if we can have as few wrong turns as possible, then that's obviously going to be the desirable. So inspection versus investigation, and the point was made earlier on that I'm taking a slightly different view on what inspection means in this context. But for me, an inspection is generally a cooperative activity with the inspector and the inspected both seeking a positive outcome. It's pre-programmed. There's time to plan, and we've just heard some fantastic stuff about remote sharing, but that takes time to plan, time to set up, and a lot of cooperation between the field site and the lab site to make it work. And I think participants have a common frame of understanding. They know what people are trying to achieve at this stage, and all this stuff is good stuff, but it may well come a little bit downstream from where I'm talking about. So for me, the investigation itself. Well, following an accident, there can be a presumption of blame, resulting in a best guarded cooperation from the site itself. I'm struggling here with my IT. Let's see if we can get it back. Yeah, the investigator needs to build rapport in order to extract an account of what transpired and why. I mean, the what may be fairly obvious. Joe got his hand trapped in a mangle. But why did he get his hand trapped in the mangle? Was he working on it? Why was the power on? What was going on at the time? There's a lot more to than just the actual what. And evidence, of course, can be perishable. So at the early stages, actions have to be taken fairly quickly. There's always a desire on scene to try and tidy up a bit, to try and make things accessible, to try and get things back into service. And of course, the people involved, the longer you leave it before you talk to them, the more their memories can be contaminated. They may start talking to their mates, they may go and look up a procedure, they may see something on the news, whatever it is, all this stuff is going on, and it is contaminating that initial raw evidence. So there's a good need to get in there quite quickly. So what does an investigation involve? Well, I suppose just keeping it at a sort of fairly high level, examination, recording the accident scene and the damage, collection of physical evidence and records, downloading of electronic evidence, and interviewing witnesses. And I'll just quickly talk through all of those because I don't have very long. But again, I'm talking really about the early stages of an investigation. So, examining the scene and collecting the evidence. It can't be done without local assistance to video the scene, secure the evidence, copy material, facilitate the interviews, and so on. You're going to need someone on site to do all this stuff for you. And your local sleuth could be anyone really. Could be a crew member from one of the ships. Could be the local harbour master. Could be the ship's agent. Could be the local lawyer. Could be a Thames surveyor. Could be a number of people. Could be more than one. Each will come with benefits and drawbacks. But you do need people on site who've got the authority and the resources to get things done for you. That's crucially important. Another important point is that ideally you should be able to trust your sleuth's discretion. You'll be asking them to get things done for you. They'll be finding things out, passing that information back. What you really don't want is this being passed on willy-nilly to all sorts of other people as well. Of course, the MAIB is involved in no blame accident investigation, and I'm not really talking so much here about information being passed on to a regulator or being passed on to the opposition's legal team, but just about contaminating your investigation. You find something out. If that then gets passed on to a witness before you talk to your witness, their information is contaminated. So the information you're getting, you want to keep it compartmentalized, and you need your sleuth, your local team, discretion to make sure that's going to happen effectively. And of course, the whole business is an iterative process. The more you learn about an accident, the more you will need to expand the scope of the evidence you need to secure. And this takes you to the size of the on-site team that you're going to get roped in to help you. If you've only got 1 or 2 people and they're very busy setting up interviews with your key witnesses, then they're not going to be available to go down to the vessel and take some key photographs and send them back to you, because you need to see that before the interviews take place, and so on and so on. So horsepower on site, a key consideration. So some challenges. Well, time zones, especially if it's their day and your night. And my experience is that the most interesting accidents always happen on the other side of the world, when it's midnight my time and it's the middle of the day in the time zone of the accident. Expertise to download data from ship systems, and there can be a plethora of these things. Obviously, the voyage data recorder, that's there for the accident investigators, but the ECDIS, engine control room data loggers, cargo loading computers, all sorts of stuff on board, and the ship's team themselves probably don't have the expertise to get into all of it. So you're going to need to dragoon in some technical experts from the manufacturers to get that data stuff off for you. And getting the data from local sources can not just involve some technical expertise, but also some cooperation. If you want the local harbour's vessel traffic services playback, then you're going to have to work quite hard at that to build that report, to get that data, and then get someone to get it off and send it to you, and so on. There's quite a lot of activity involved in just getting data, which is all going to be sent back to you. Chuck was talking about secure portals, drop boxes, whatever it happens to be. You're going to need some really big data storage, because particularly if you're talking about high definition CCTV, multiple cameras, then we're talking about multiple terabytes of data. If you're talking about live stream and video, again, big data channels, and all this stuff needs to be there either immediately for an immediate reconstruction or conversation, or to send the data down for later reconstruction as it goes along. And I would suggest also extensive access to information resources. It's amazing as accident investigators how much information we pick up from the ship itself. We want to know what the weather forecast was. For example, I'm talking now about a nautical accident. Well, we would look to see what weather forecast the ship had actually obtained. But it may not be quite so easy to find out what weather forecast the ship obtained when you're working remotely. You want to know what the weather actually was, weather forecasts, weather hindcasts, sailing directions, AIS charts, and so on and so on. Lots and lots of stuff. And access to all this lot usually requires setting it up well in advance and having contracts to get it available to you when you need it. I'm going to spend the last couple of minutes just talking about witness interviewing, because I think it is probably common ground that marine accidents, everyone says 80% human factors, 20% technology. Well, we can discuss that all day, but the point is, even if it's a material failure, someone was probably involved in maintaining or inspecting that piece of equipment at some stage. Humans come into it at all points. So witness interviewing is a key part of understanding why something happened, and not just what happened. So an initial question: are you going to need interpreters? My experience in this sort of this League of Nations crewing that we seem to be in at the moment is you can end up with interpreters in 3 or 4 different languages working as part of your team to facilitate witness interviewing. Although the language on board might be Russian, it might be English, it could be whatever. The native language of many of these speakers is not going to be the ship's language, and an interpreter is what's going to help you get the best stuff out of them. So, is the interpreter going to be co-located with you? Are they going to be the witness, or are they going to be a third party to a phone call or video call? We've used all. They all come with pluses and minuses, but the third party ones are possibly easiest to obtain, but sometimes the least useful, particularly if they drop out of the call halfway through. You have to reset it up. The contract gives you a different interpreter when you re-establish a connection. There can be some real challenges to third party interpreters. If you're using local interpreters on the scene, are they independent? Are they people that you can trust and you can brief to give you an unadulterated account of what the witness has said? Or are they actually in the pay of someone else, and all this information is being fed back and potentially contaminating your investigation? And if it's a local interpreter that you've brought in to help you, well, can they translate technical terms? So as we start talking about deck houses and wheel houses and tiller flats and rudders and steering gear and so on, is this going to get translated in a sense that makes that is useful to you? Phone calls or video calls. Well, I mean, phone calls are obviously easier to set up, but video calls can be much more engaging and therefore much more productive. But if you're dealing with third nation people who perhaps are not particularly used to setting up a Teams meeting, this is where your sleuth comes in. They set up the Teams meeting, they get it all going. In comes your witness, sits down, starts to do stuff. This is where you've got to decide: is your sleuth going to stay for the whole of that interview, or are they going to go out? What happens if the call drops out halfway through? Challenges at every stage if you don't have your own people on site. And the final thing which I really want to run on, I've got one more slide on this, is the self-imposed time pressure, which can result in interviewers taking mental shortcuts. And again, as someone who's been in the business now for a few years, I can vouch for the fact that the first account that I hear tends to affect my judgment. It's called anchoring bias. It's something that sits there and is in your head. And then after that, what you want to do is you want to put in bits and pieces that help confirm that first story. This is confirmation bias. You're looking for the things that support that story that's in your head. And this is where the discipline of asking the same questions each time, making sure that you are not locked onto a particular thing is really, really important. And of course, as humans, it's our natural tendency to fill in the gaps. And for those of you who've been doing a little bit of human factor stuff, you'll be familiar with things called scripts and schemas, pre-existing knowledge structures in our memories. And they basically act as cognitive shortcuts to help us make sense of our environment. If I was to say to you, I sat down on the park bench to eat my sandwiches and watch some children playing with their dog, you could probably conjure up that scene. And it might be a sunny day, and I bet that your dog is different to my dog, your park is different to my park, you've got a different number of children to the number of children that I've got. But we've created this immediate mental image. It's a cognitive shortcut. We like the story, we're on the program, we know that we're talking about a park and some children playing with a dog. And these are shortcuts that we just intuitively make all the time. And things that fit with our schemas capture our attention much more easily. Schemas are very easily formed, but they're very resistant to change. So to make a story fit our schemas, we can, and this is all going on subconsciously in our heads. We edit it. We admit or dismiss detail that seems irrelevant. We hear it, it's on the tape, but it hasn't necessarily registered in our head. We can invent details so the narrative makes sense. How did he put sugar in his coffee without a spoon? Well, maybe he just tipped it in. But again, we invent details in our heads to try and make things make sense. Sometimes we can even change the order of events and we can attribute actions to others. The point being that this is a human it's a human failure, if you like. We do this with all the stories, all the narratives we hear. We take these things in, and it just becomes part of this picture we're forming in our head. I would suggest that when we're doing this thing remotely, it is much easier to fall into these traps than it is when you're actually in the room. Having a 3-hour interview behind the green baize door with someone is something that perhaps goes on reasonably commonly in an accident investigation. But when you're doing it, when you're doing it down the line, talking to someone, it's much harder to keep their attention focused on the screen and doing it for a long time. So, in summary, remote accident investigation can be highly challenging, whilst dealing remotely with the accident scene will be demanding, time-consuming, frustrating. I think perhaps a bigger risk to a successful investigation in these early stages is investigators subconsciously filling in the blanks to get the job done. We'll get there in the end, but if we can avoid some of those wrong turns on the way, then that's what we want to try and do. And I think, Chuck, that's me. And so, for the sake of time, I'll hand back to you and stop sharing my screen.
Great. Hey, thank you so much, Andrew. I think, Alex, you are up next, so you may share your screen when ready.
Thank you very much. I will do that now. And just let me know when you've got it. That should be you.
Yeah, it looks good, Alex. If you want to jump to slide mode.
Excellent.
Perfect.
Thank you very much. Good afternoon, everyone. Alex Level-Smith, Director of CLS Europe, here to speak to you briefly about the use of drones in remote investigations, specifically in the maritime environment. Now, there are a number of factors to consider when employing a drone or UAV in any scenario, but it's particularly pertinent either in a harbour, port, or even a float situation. Starting at the top, regulatory compliance is, as you can imagine, key, but this is an area where aviation regulation meets the regulation of the supported industry. In this case, it could be oil and gas, could be a shipyard, could be a bunkering operation. The automation versus training point that I highlight really speaks to the fact that there are systems out there that can be purchased or contracted that will fly autonomously, gather data autonomously, but they perhaps don't yet offer the flexibility of a system with a well-trained pilot. And that balancing act is key depending on the output you require. Connectivity has been mentioned by both esteemed speakers, and I shan't reiterate it other than to say that bandwidth and cellular data are key depending on where you are. But I suppose, good news is there are many complementary technologies now available to cover all of these areas, whether operating on the spectrum of a quick search and rescue type response or right the way through to a longer term evidence gathering effort that might require very large amounts of data gathered from the air. To put that into a pictorial context for you, in our experience operating with maritime clients, these are the areas that are increasingly coming under scrutiny and request. So surface oil and MARPOL monitoring, whether using AI or manually, is key. A wide area survey of the exterior of a vessel or infrastructure, or indeed internal structure, has become more prevalent. The internal structure investigation is particularly interesting, particularly when one considers that a device flying inside a building or ship's hold doesn't have GPS reception, so it's operating with different technologies and different means of control. Air particle analysis regularly features in our work now, particularly since IMO 2020, and that's particularly the Danish maritime industry has really taken the lead on the use of drones for air particle analysis. And ultimately, the data types coming off each of these systems can be disparate and need collation and effectively a form of structure before they can be valuable to the customer. And that's where, whether it's an international dissemination through a portal, as described previously, or even local dissemination, data husbandry, if you like, becomes all the more important. To put this into context, I've just highlighted a couple of tasks we completed for two very different maritime requirements to really put into perspective some of these points. So this image was taken from the drone on task, and in this case, like many UK ports, the client had a facility they needed examining that sat within some very dense controlled airspace. So there's a civil aviation, or in our case also Irish aviation authority liaison required. Clearly the harbour master and local maritime stakeholders are key, as are police, whether they're harbour police or local authorities more widely, and also the local health and safety policies of the client, the drone operator, and also any third-party investigative agencies that may be involved. In this particular scenario, I draw it to your attention because we had a number of layers of connectivity, as I call them. Our pilot in this instance we positioned towards the entrance to the dry dock, so he had maximum visibility and could maintain his legal requirements for seeing the drone, seeing other airspace users, and other maritime hazards that might be approaching. The client in this case was sat with a vehicle that we had kitted out with a cellular node, so we could maximize our bandwidth in an area that has some cellular coverage, but perhaps not what we need to stream HD video. And that first layer of connectivity allowed the client to control the drone camera. So legally, they could control the camera system, other sensors from the vehicle, while the pilot maintained full control of the aviation system, if you like. And then another step back, we actually had, in this case, it was actually done with YouTube, but other and custom options were available. A custom remote viewing system for the parent company, if you like, which is based in London, for them to see live what we were seeing and pass messages to their representative on the ground to move the camera. What's interesting is that by setting that up, we yielded some extra requirements on task. And I bring this image up to show that the same machine was then asked to lower its altitude and take a picture of the dock entrance, which at the time wasn't part of the task. But once they saw what was possible, in this case, the client was keen to have a closer look at other parts of their facility. To really show a different version of the same technology, here's a separate task we had. This was on a harbour side for a warehouse survey, and an insurance firm was looking to cost a new roof and a claim. And here you can see a number of areas of rust and degradation, in particular a hole. Now, we can use either manual methods to identify these kinds of damage areas post-production, if you like. We've also started using deep learning and writing our own kind of deep learning CNN software, which I can talk about perhaps offline with those who are interested, to filter through thousands of these images, particularly over a large area, and identify those images where damage is present. And that really optimizes how we then make use of that.
Excuse me, Alex.
Go for it, Les.
Yeah, I'm sorry. You seem to have frozen and we haven't moved on from the doc.
Oh, stand by. How's that?
We're seeing the doc image, Alex. I'm not, you may want to.
I'll just unshare and reshare very quickly.
Yeah, there we go.
Yeah, there you go.
Do that. That's a good idea.
Stand by. How's that? Not yet. Stand by.
There we go. Now we're seeing your doc image, or your, I'm sorry, your roof image.
Excellent. I'll just recap. So the roof, a single image of a roof, damage highlighted manually in this case, but we're increasingly using deep learning to take in a large number of these images from a portfolio and identify this damage autonomously so that we can optimize the time, whether it's an inspection client or a survey client, for minimizing time spent filtering through photos, essentially. What this leads on to, and I'll conclude on this one, is the fact that the right system can yield results that people didn't think possible with drones even a year ago. So these images are taken with the same machine, a different camera system, and you can see on the right, you can identify the layers of repair on the roof. You can see how the degradations occurred. And this allowed, in this case, our client to make an assessment of how previous repairs had taken place before they acquired that particular piece of infrastructure. I'll pause there and conclude, but I'll obviously take questions via the means of the other speakers. And thank you very much for your time.
Thank you, Alex. I see there are a number of questions in the chat, and I think that Matt Jeske is coordinating those, or are you doing that?
Yeah, I'm happy to do that. Les, let me jump over and look at the questions we've got here. So there's a question for Andrew. Andrew, do you think remote interrogations present new challenges in regards to cybersecurity? For example, how the recordings will be used, who has access to the video, audio feeds, etc. Do you always record face-to-face interrogations?
Oh, interrogations. Yeah, I hate the word, but interviews. Yes, we do always record. And in the UK, we have the legal right to record interviews by whatever means is appropriate. So it could just be audio, could be audio and visual. Those recordings in the UK context are protected by primary legislation. They can't be used in a court of law, and we don't let them out. So it is particularly protected information. The challenge for us is what's going on in the room at the other end. And so at the start of any interview, we would spend a bit of time talking through the pros and cons of recording the interview, what's going to be done with our copy of it, and what needs to happen at the other end to ensure that everyone's on the same playing field and understands what they're letting themselves in for, particularly if someone at the far end where we are not is taking what I would call a covert copy of the interview.
Mm-hmm. Mm-hmm.
And Chuck, there was another question. This is Matt Kenner with ESI, and it kind of ties into what Andrew talked about. And somebody asked about NDA, which I'm reading as non-disclosure agreements with respect to accident reconstruction. It's something that you would have to definitely, with all the parties involved, front the issue, get it involved in the protocol and whatever setup you need. But Andrew points out the key, you have to understand that you can control the recordings that you're taking. They can go to secure servers. The portal can be secure. You can limit the number of people that might be attending the meeting, but you don't know if somebody has a camera on their desk in another room. So it's definitely an issue both on the interview side, as Andrew alluded to, and on the accident reconstruction side. You can set things up beforehand, but you do need to be aware that there's maybe the possibility for security breach isn't the right word, but necessarily, but there are opportunities for somebody to go outside of the agreements, but it's definitely something that should absolutely be fronted, and it's kind of maybe a newer issue because of the ability for somebody to do something in a room half a world away.
Yeah. Yeah, it's a great point, Matt. I mean, it's someone could potentially record conversations in an in-person setting, but it's so much easier to do it, in this remote environment, and I think that is a consideration. Andrew, I've got another one. Oh, I'm sorry. Go ahead.
Yeah, and somebody just followed up. I think it goes with what we're talking about. So the question is, has remote work been accepted by the U.S. courts? It's actually pretty new with respect to that. It's not fully been tested, but many of the tools, stereo microscopy, SEM, all the data that's being developed, there's not actually a new tool there. Those are all accepted. Laser scanning is a really, really fancy tape measure in many ways, right, with respect to the data you're getting. So I don't think that comes into question and I'm not a lawyer, but from a legal perspective, the question becomes, has your witness physically seen the part? And that sometimes can be at least a perception issue. I think that especially into the lab environment, there's going to be a number of instances where the expert's seen the part, maybe they've seen it at the ship or at the dock, and then a subcomponent goes to a lab and they send an associate. They can't make it, but they can attend remotely. I don't foresee that there would be a big issue because in that instance, they've seen the part, they've seen the component. The laboratory data is typically something that you would rely upon that's developed by an independent lab, say, and shared across all the experts. So it may still be in question. It's to be determined, I guess, and developed, but I think the basis of it is data that courts have been working with and accepting for years.
Yeah, excellent. Thank you, Matt. Couple of technical questions popped up here a little earlier, and one is, how long does it take to 3D scan a location, for example, in an engine room? And as I mentioned, the 3D scanner takes about 8 to 12 minutes, depending on the sensitivity you set up for the scan, to take a single scan. To create a complex point cloud of a space like an engine room, you take a number of scans and essentially stitch them together to create the overall point cloud. So it's not unreasonable to spend half a day to a day scanning a complex environment. We have been on sites, for example, like the refinery or large warehousing facilities, where we've spent a week collecting laser scans and then combine those all into one large scan. So it depends on the size and complex nature of the scene, but typically most of the time half a day to a day captures what we need in a typical scene. Another technical question was around the VR and what platform we're using for the collaborative VR. We're using a combination of tools to create this collaborative environment. Unreal Engine is the platform upon which we build the actual VR application, but sharing it involves sort of a number of things that we're doing, developing on our own at ESI for that environment. So because it's important to us not only to be able to share, but also to be able to do things like take measurements and share points of view and other things that we find useful when we're sharing in VR. And Les, I see you've got your hand up.
Yes, a question for Alex. Alex, are there any particular challenges for harbour authorities and lighthouse authorities, especially in the UK, for using drones for remote inspection, say, for navigation marks, etc.?
Thanks, Les. I say there's two that stand out. The first is the line of sight limitation under UK aviation law. So there's a 500-metre limit, effectively, and it's very similar under Part 107 in the US, between the drone pilot and the physical air vehicle. In terms of doing it autonomously for things like ISPS compliance and data gathering, the technical barriers really have been removed significantly in the last couple of years in terms of saltwater tolerance of the systems smart cameras that can identify lights, whether they're on or off, or simply, covered in some kind of material that requires a jet wash. So I think really the main barrier is a legislative one rather than a technical one. That said, the CAA is alive to it, and I think COVID, ironically, some of the progress that's happened around COVID with beyond line of sight package delivery has now bled across into the wider aviation regulation for example, offshore buoy inspection at a kilometre, and that's something that we're closely involved in at the moment with the CAA.
Thank you.
Great, thank you, Alex. I saw another hand up. I think it was Franz. Is that you still have your question? You may be muted. If you need to unmute your mic, feel free to do that. Everybody's sort of universally muted here. Okay, well, hearing none, there was another one for Andrew. Andrew, do you find that eyewitness interrogation actually presents the same challenges across different engineering disciplines and accident scenarios?
Pretty much. I think, like most accident investigation branches, we have a multi-skilled workforce. So we tend to take marine professionals and we train them to be investigators. We don't take policemen and train them to be mariners. So we will always try and put a former master mariner, a ship driver to deal with the nautical accident, an engineer to deal with an engineering accident, and so on and so on. That only works so far, and particularly on the engineering side, as you start to get novel technologies, it could well be that all you can do initially is do a data capture, standard sort of stuff, and then you need to do a bit of learning before you can then go to the next depth. Less challenging, I would say, in the nautical stuff, but yes, we use technical experts to do the questioning, and so it's pretty much the same across the board.
Right. Thank you, Andrew. Well, I think that's pretty much the questions here. Les, I see you have your hand up.
One more question for Alex. Sure. Alex, what sort of applications do you have for anti-piracy?
So we work with systems that, for example, will autonomously track a speedboat out to a couple of kilometres and engage a speedboat via non-lethal means. And that's something we actually have brought together a number of other businesses to put that package together, because it touches on physical camera security at longer range, maritime radar to a certain extent, and then UAV GPS guidance, which is an ever developing field, but one that's becoming more and more robust. So from our point of view, we certainly have advised and provide systems to clients who want to for want of a better term, reach out and touch a piracy threat without creating a lethal engagement scenario, and actually have that deterrent effect long before effective weapon range is reached or law of armed conflict thresholds are met. So anti-piracy is certainly an interesting one, and it's one where drones have new applications, but they're the same technologies at the core foundation. It's the same technology that we've spoken about today, reapplied and somewhat reprogrammed to interact with existing ship security systems or indeed platform security systems.
Great, thanks, Alex. I think I notice our numbers are dwindling off because we've gone past the witching hour of 18:15. So it just remains for me to thank Chuck, Matt, Dan, Andrew, and Alex, and especially Matt Jeske, the technical manager behind the scene, for producing today's webinar. Thank you all very much for your time, and especially those that are on holiday, taking the time to do this. And thank you all for participating in the Centre's educational program. Thank you very much.
Thank you, Les.
Thanks, Les.